Okay, I just did this problem, and after I finished, when I was hitting, end, I noticed that Mobius did this a totally different way, which is fine because there's more than one way to do something. But what they did is they started with the fact that they have coefficients here, and so they use that rule that says, put them back into their exponent position. So they made this log base 8 of a 2 to the 6th plus log base 8 of 64 over log base 8 of 4 to the 3rd. Okay. But what they did next is they noticed that all of these were log base 8s. And there was enough enough 2's in all of this. Instead of 2 to the 6th, let's see. Instead of 2 to the 6th, 2 to the 6th is actually 64. But what they did is they wrote this as log base 8 of an 8 squared. They made 64 an 8 squared. And then they went over here, and here's another 64. So they wrote that one as log base 8 of 8 squared also. And then technically 4 cubed. If you take 4 and raise it to the 3rd power, that too is a 64. So they wrote this one as log base 8 of 8 squared. And then they used that logarithm rule that says if you have log base A of, actually I think they used the letter B in this book, log base B of B raised to the x power, the answer is just the x power, because the log here, which has a base of B, and the base here, they literally like cancel each other out, so you're just left with the x. So if this log base 8 and that base 8 cancel out, you're just left with the 2 plus, and then this log base 8 cancels this 8, so the numerator becomes a 2, and this log base 8 and that base 8 cancels, and you're left with this 2 here. All these 2's you're left with. So this is really 2 plus 2 divided by 2 is 1, and 2 plus 1 is 3. Honestly, I probably wouldn't have done it that way, but it worked. It did work. So if you're reading Mobius's explanation, that's what they did. So just wanted to go over that method as well.